This is Lodestar, a navigation integrity engine for GPS-denied drones. The drone flies a planned route, and its estimated track in cyan sits exactly on the true path. The dangerous failure in contested airspace is not drift. It is a confident, wrong position, flown straight into a wall. Lodestar is built so the drone knows where it is, and knows the instant it cannot be trusted. The drone crosses into an electronic warfare jamming bubble and GPS drops. There is no mode change. The estimator hands off to visual-inertial odometry and keeps tracking, holding drift under 1%. The orange dead reckoning track, running on the inertial sensors alone, has already begun to peel away toward tens of meters of error. Now the case that breaks naive VIO. A moving convoy crosses a feature-sparse clearing. Stock visual odometry with masking off locks onto the moving vehicles and flies off, past 70 meters of error in red. Lodestar rejects those dynamic features. Integrity drops to amber, honest about having few static features, but the track holds. Then the honest test. The drone enters a dark tunnel and visual features collapse to zero. No estimator can produce a trustworthy position from a scene it cannot see. So the integrity monitor flips to red. Position not trustworthy. It triggers return to home at 52.5 seconds and refuses to bluff a position it cannot stand behind. The flight is scored against independent ground truth the estimator never sees. Dead reckoning drifts 31%. Stock visual odometry, 29%. Lodestar holds 0.9%. And it flagged the unobservable tunnel 100% of the time, with near zero false alarms on the healthy denied leg. The two strips below read the whole flight at a glance. The first is position error against ground truth. The Lodestar line stays flat near the floor, while dead reckoning and stock odometry climb off the top of the chart. The second is usable visual features. They fall to zero inside the tunnel. That collapse is the signal the monitor uses to abstain. Every layer is a control. Turn off the stock odometry overlay to compare Lodestar against ground truth alone. Turn off dead reckoning to isolate the vision solution. The whole run is deterministic and seeded, so it replays the same way every time, frame for frame, which is what makes it a fair benchmark. The tunnel is a hardware trade, not magic. Toggle the simulated LiDAR fusion and replay. Now the tunnel is observable, integrity holds, no failsafe fires, and drift drops to near zero. The report is honest about the cost. LiDAR adds 250 to 400 grams of payload and up to 12 watts of power. This is the durable idea. The integrity monitor lives outside the estimator because trust must not depend on the thing being trusted. A better model closes the accuracy gap. It does not answer whether the position can be believed. That answer is the product. Every flight exports a receipt. Download the raw JSON or a printable flight integrity report. There is even an optional AI-drafted technical narrative, the only language model in the demo, and it sits entirely outside the flight loop. The gate decides. The model only describes. Open that report, and it lays out everything a technical reviewer checks. Trajectory accuracy against ground truth, the abstention verdict, the throughput target, and a plain disclosure of what is real and what is simulated. This is the receipt a defense or mining buyer can actually audit. From Veriprajna, Building True Intelligence.